In this video, we are going to define molar mass and also the mole. Molar mass. We just finished talking about relative molecular mass, and we calculated the relative molecular mass of compounds, of molecules as well too. There was something I said there, that relative molecular mass, alright, there is no unit there, we don't put any unit there, it doesn't have units. Molar mass is simply relative molecular mass expressed in the unit of grams per mole. Molar mass is simply formula mass with the unit grams per mole added to it. When you are given a substance and you are asked what's the molar mass of that substance, by definition, molar mass is simply the mass of 1 mole of that substance. So if you have 1 mole of a substance, what is the mass? Okay, like if you weigh it, what would be the mass of 1 mole of that substance? Remember, you can have 2 moles, 3 moles, even fractional moles, 0 point something moles, okay? But molar mass is interested in the mass of just 1 mole of that substance. That's the definition of molar mass. Like I said, the unit of molar mass is grams per mole. Here on the board we have it. Grams per mole, that's the unit. In short form, the mole is written as MOL. Are you getting it? MOL as unit. So if you are asked to find the molar mass of any compound, any substance, all you need to do is calculate the relative molecular mass. Once you get the answer, put grams per mole, and you have gotten the molar mass. So do you think it's difficult? Very simple. You already know how to calculate the relative molecular mass of a compound. So you follow that way, get the relative molecular mass, put grams per mole. That gives you the what? Molar mass of that compound. Now let us define the mole. Let's talk about the mole now, right? The mole. The short form of it is MOL. So what is the mole? The mole is simply the number of atoms in exactly 12 grams of carbon-12 isotope. What do we mean by that? Saying that the mole is the number of atoms in exactly 12 grams of carbon-12 isotope. Now, if I give you carbon, the mass of carbon, alright, is 12. The mass of carbon is 12. So how many atoms are contained inside that 12 grams? Exactly how many of the atoms are inside 12 grams of carbon? That is what we call the mole. The number of that atoms in 12 grams of carbon is what is called the mole. Mole is also used as a unit. Okay? If you give it a substance and I ask you how many particles are inside that substance, how many particles, how much are they? The unit we use in expressing, the unit we use in measuring the number of particles in any substance is also called the mole. Can we now define 1 mole of a substance? Because we've been talking about this mole, and by standard you see that we related it to carbon-12. Carbon-12 is our base, is our foundation. It is the standard in which we use in our definition. So what is 1 mole of any substance? Here on the board we have the definition. 1 mole of any substance is the amount that contains as many elementary entities. When you talk about elementary entities, it includes atoms, molecules, ions, electrons, even other particles, okay? So the 1 mole of a substance is the amount that contains as many of these elementary entities. Just the same way as we have the number of atoms in exactly 12 grams of carbon, just like we defined here. Remember, I stated from here that the mole is the number of atoms in exactly 12 grams of carbon-12. So 1 mole of any substance now is simply the number that contains as many elementary entities The elementary entities, like I said, include atoms as well too. So we could say that the mole is simply the amount that contains as many atoms. Does that make sense, right? As the number of atoms in carbon-12. Here I gave you a note for you to understand what elementary entities of matter, what they are. Atoms, molecules, ions, electrons, and other particles. Next, we are going to see the relationship between the mole, the mass of a substance, and one number that we call the Avogadro's number. Then I'll give you one important formula as well too, which relates the number of particles that is contained in any element to the number of moles and to the Avogadro's number. A very important formula, okay? In this video, I'll be giving you some important relationship about molar mass, number of moles, and one number called the Avogadro's number. Remember, we've defined the molar mass of a substance. We said it is mass of 1 mole. We've also defined the mole. The mole is simply the number of atoms in exactly 12 grams of carbon-12. And defining it for a particular substance, we said that it is an amount that contains as many elementary entities. Just the same way as we have number of atoms in carbon-12. That is in 12 grams of carbon-12. So you see there is this relationship between all these things we've defined. And here on the board, we want to look at them. I've brought out 2 of them majorly, which we formulated, alright, as an equation or a formula, and then I gave a general note down here. So the first I'd like us to talk about is the relationship between the number of moles, the number of particles, and the Avogadro's number. You can say that, which we call equation 1. The number of moles, which we use small letter n to represent, is equal to the number of particles, which we use capital letter N to represent, then divided by Avogadro's number. We use L to represent Avogadro's number. I've defined the meaning of each of those terms there. What we have here, look at the formula written with alphabets, with letters. So call it equation 1. L, which is Avogadro's number, is a constant. The value does not change. And the value is 6.02 times 10 raised to the power 23. 6.02 times 10 raised to the power 23. Sometimes this 0.02 we neglect it. We just have 6 times 10 raised to the power 23. It's still the same. Are you following? So that is one of the formula I want you to know. Very important formula in chemistry. The second one we have it here is the relationship between the number of moles, mass, and molar mass. The number of moles, small letter n, is equal to the mass of that substance, small letter n, divided by molar mass, capital letter N. That we call equation 2. I use the letters to write out the formula. This small letter m is simply mass, and the unit is in grams. The unit is in what? Grams. Molar mass, we've already talked about the unit, grams per mole. Please take note of this relationship, very important. 1 mole of any substance contains the molar mass of that substance, and it is equal to the Avogadro's number. So you want to always remember this relationship, very important, okay? Every 1 mole of a substance contains Avogadro's number, and it is still the same as the molar mass of that substance. Now we're going to pick questions and solve using these formulas that we have here on the board. In this video, we will be solving this question. And you know, one thing that is very interesting about this question that I am going to be solving for you now is that we are going to use 2 approaches to solve this problem, and these 2 different methods would give us the same answer. So you will decide which one you want to use. Let us read this question and see. what is the mass of 3 moles of oxygen, O2? This oxygen is oxygen molecule. Then we're given the relative atomic mass of oxygen atom, 16. Now, what do we do about this question? We want to get to know what we are looking for. We are looking for the mass of 3 moles. We don't know the mass of 3 moles of oxygen. Now, there is something I told you in the previous video. I stated that 1 mole of every substance contains Avogadro's number, and 1 mole of every substance is equal to the molar mass of that substance. 1 mole of every substance is equal to the molar mass of that substance. Now, what is molar mass? Remember I said that molar mass is mass of 1 mole. That's what we defined it to be. And I told you that the way we calculate molar mass is exactly the same as the way we calculate RMM, that is relative molecular mass. The only difference is that molar mass will have units of grams per mole. So if we know that 1 mole of every substance is equal to molar mass, we can use that idea to get the answer of this question. 1 mole of every substance is equal to molar mass of that substance. It becomes a standard. It becomes a foundation. Now I'm going to tell you something to understand how important the fact that 1 mole of every substance is equal to molar mass of that substance. I'll give you an example to help you understand this. Let us assume that I want you to buy orange from me. I want you to get orange. And then I tell you, hey, dear student, please go get me orange. But 1 orange is sold for 10 naira. That is, every 1 orange is sold for 10 naira. And I want you to buy 3 oranges. How much will I give you? I know you can think about that, is that not so? But let me show you mathematically what we do. As a standard, you know that 1 orange is equal to 10 naira. Okay, just a simple mathematics, direct proportion, that's how we call it in mathematics. Now, 1 orange is equal to 10 naira, that's the standard. So if I said you should get me 3 oranges, buy 3 oranges, how much will I give you for that? I will say, I don't know. That I don't know now is X. That X now would be like, okay, let X naira be the amount that 3 oranges are being sold. So from here you calculate for X. Since you have orange here, they will cancel out, you cross multiply and calculate for X. You know, this will give you X times 1, which is X, equal to 3 times 10 naira, which will give you something like this, you know, and then X will be equal to 30 naira. So for the 3 oranges, I'll give you 30 naira to buy it for me. So this standard is very important, and that's the same thing I want you to understand about this question. We are to calculate mass of 3 moles of oxygen, but we know that as a standard, 1 mole of any substance is equal to molar mass of that substance. We'll use that to build this up. Are you ready? Okay, let me wipe this. I will start by saying, here we're giving number of moles to be equal to 3. So I will say let mass of 3 moles of oxygen be equal to, I don't know. So I will say let it be equal to X. But as a standard, we know something. But we know that 1 mole of any substance is equal to molar mass of that substance. Molar mass of that substance. This is the standard. So what will I do? I will come here. What is the molar mass of this oxygen given to me? I'll say molar mass. I'm going to write molar mass of O2. Molar mass of O2 is equal to 16, the relative atomic mass, times 2. We've done that already, you know, which will give us what? 32 grams per mole. 32 grams per mole. Relative atomic mass of oxygen is 16 multiplied by the 2 atoms. So the standard will now be, it means that 1 mole of oxygen, O2, is equal to molar mass as a standard, and the molar mass is 32 grams per mole. 32 grams per mole. Alright? So the mass of 1 mole of oxygen is 32. every 1 mole of oxygen molecule will contain 32 gram mass. Therefore, if I know that this is my standard, 3 moles now, therefore 3 moles of oxygen O2 will be equal to I don't know. Remember, we say it should be equal to X. So from here, what will happen? This mole will cancel out. You now cross multiply. So I will cross multiply. If you cross multiply, this X will multiply this, we get X times 1. Equal to this 3 will multiply 32, we get 30. You will get 3 times 32 grams per mole. 32 grams per mole. So if you solve this, the value of X will give you what? 96. Alright, 96 grams. 96 grams. If I like, I put it per mole. If I don't like, I'll leave it like that. Okay? So in conclusion, therefore, I can say that 3 moles of oxygen, 3 moles of oxygen is equal to mass of 96 grams. Is equal to 96 grams. Answer. This is one way I can solve it. Method 1. Now method 2, or I can use the formula directly. From the question, I know that the number of moles, small letter n, is equal to 3. 3 moles, that's what I know. And then they're asking me to find the mass of these 3 moles. I don't know. Small letter n, the mass, I don't know. But I know molar mass of oxygen, capital letter N. Molar mass of oxygen, this oxygen molecule, is 32. So I will now use this formula. N equal to mass over molar mass. If you use this formula, what does it mean? Let's substitute and now see what we will get. It implies that in place of N, I'll put 3. Mass, I don't know. I'll have N divided by molar mass, which is 32. Molar mass is here grams per mole. So from here you cross multiply, you know that. So that the mass will now give you 3 times 32. 3 times 32 will give us what? 96 grams. Answer. So it's the same as this. You can use the formula directly and get your answer. Is that okay? The choice is yours. I've put you through all the things you need. I hope that our previous question, number 1, was clearly understood after I solved the question using 2 different approaches. The formula method and what I would call the step-by-step analysis method. We have this next question on the board here. I'm going to solve again using the 2 approaches, the 2 methods. But first I'm going to use the formula method, after which I will use the other approach. Remember, having a standard. From that standard, we can now get what they're asking us to find. Please, come with me. Let's read this question on the board. How many moles are there in 20 grams of calcium trioxocarbonate 3? How many moles are there in 20 grams of it? So how we solve this problem? First, let us use the formula method. Alright, so using the formula method, I've given you the formula already, from our previous video. So what do? Let us declare our data first. I've told you, I think in one of our class in physics, that whenever you're solving a question, calculation, it's important you declare your data first. Bring out the information you know and what you're asked to find. So from the question, they're asking us how many moles are there in 20 grams of calcium trioxocarbonate 4. So the mass of calcium trioxocarbonate 4, whose mole they want us to get is 20 grams. Gram is the unit of mass, that we studied that under units, quantities and their units in physics. So mass M is 20 grams. They ask us to find how many moles. Moles. We use small letter n for our moles. We don't know. But from the question, you can calculate the molecular mass or the molar mass. Alright? Just the same way you get RMN. But good enough from the question, they've given it to us. Calcium trioxocarbonate 4 equal to 100. So the molar mass was given to us. Capital letter M equal to 100. I'll put the units, grams per mole. Maybe to write a mole here, 100 grams per mole. Then I'll now write recall. We have the formula. Recall, we know that number of moles is equal to mass divided by what? Molar mass. We can now substitute and see we are looking for number of moles. So I can now write number of moles, I don't know, is equal to, let's substitute now. In place of mass, small letter m, what do I put? 20 grams. So it's going to be 20 grams divided by, in place of capital letter M, molar mass, I'll put 100 grams per mole. 100 grams per mole, that is divided by mole. If I don't like, I can just forget about the unit. When I am done solving, I'll put back the correct unit for mole. The unit of mole is MOL, you know that. From here, this gram and this gram will cancel out. This thing you are seeing here now is 100 over mole. Mathematically, that mole will go up. Okay? So the number of moles N will now be 20 over 100. 20 divided by 100 mole. So what's the answer? N is equal to 0.2. You know from here, these last zeros we cancel out. Then 2 can go into 2, you have 1. 2 can go into 10, you have 5. 1 over 5 is 0.2. So 0.2 moles. We can conclude because we are asked to find how many moles are there in 20 grams. So I can say therefore, there are 0.2 moles in 20 grams of calcium trioxocarbonate 4. Let us use method 2, the analysis method. Method 2. You know, here we have gotten our answer here. Just put that. Answer. Now method 2. In method 2, all we need to do is to say, okay, how many moles are there in 20 grams? We don't know. Let number of moles in 20 grams of calcium trioxocarbonate 4 be equal to X. I don't know that. But by standard, we know that every 1 mole will contain molar mass of that substance. So I will come and then I'll write out the standard. Molar mass of calcium trioxocarbonate 4 is 100. So I'll say, but I know that 100 gram per mole of calcium trioxocarbonate 4 is equal to 1 mole. Or simply 100 grams is equal to 1 mole. So I don't want to put per mole, no errors, still okay. That is the standard. 1 mole of any substance will contain the molar mass of that substance. Therefore, the question gave me 20 gram will contain how many moles? I don't know. The grams will cancel out, and then you cross multiply. X times 100 will give us 100x. 100x will now be 20 times 1 mole will give us 20 moles. Now I'm looking for x, so I'll divide both sides by the coefficient of x, which is 100. Let me write it. It implies that x will be 20 divided by 100. You know, divided by 100, x will be left. Look at it. Divided by 100, you have 20 over 100. Therefore, x will be equal to 0.2 moles. 0.2 moles. And that's the number of moles that is present in 20 grams of calcium trioxocarbonate 4. Make your conclusion here, please. Make your conclusion. The question did not ask us to find x. I was the one that called x to be the number of moles in 20 grams. So conclude, therefore, there are 0.2 moles in 20 grams of calcium trioxocarbonate 4. It is time we are going to solve problems on percentage by mass of an element in a compound. We are going to learn about percentage by mass of an element in a compound. What is this? The percentage by mass of an element in a compound is simply the percentage of that element in that compound. And that percentage is usually interpreted as mass of the element in the compound. Let us assume I give you tetraoxosulfate 6, and I ask you what is the percentage by mass of sulfur in that compound. It will simply be the mass of sulfur divided by the mass of tetraoxosulfate 6 as a compound. Then you multiply it by what? 100. That will give you the percentage by mass of sulfur. And that percentage by mass, in that case, is interpreted as the mass of that element, which in this case I gave you as an example, sulfur in tetraoxosulfate 6. So all we need is this formula. Percentage by mass of A is an example of an element now in a compound, is equal to mass of that A in the compound divided by molar mass of that compound containing A. Then you multiply whatever you get by 100. So we have these two questions on the board here. Let's see how fast we can solve these questions. Is that okay? The first one, calculate the percentage by mass of oxygen in HNO3. HNO3 is trioxonitrate 5 acid. You can see hydrogen that it contains, trioxonitrate 5 acid. We're given the relative atomic mass of each element there. So number one, right, I just want to solve that straight on, okay? What we are looking for is percentage by mass of what? Percentage by mass of oxygen. Okay, so percentage by mass of O2 in HNO3. In HNO3. It will simply be equal to, using this formula, mass of oxygen in that compound. And oxygen here, how many atoms do we have? 3. So it's going to be 3 times 16. You know, relative atomic mass of oxygen is 16. And there are 3 atoms there, so it will be 3 times 16. Alright, let me remove these 2 here so you don't get confused. Okay? Percentage by mass of O, oxygen, in this acid is equal to the 3 atoms times the relative atomic mass of oxygen, which is 16. Then we are going to divide it by the molar mass of the compound containing A. The compound containing A is trioxonitrate 5 acid. So let me bring down the calculation here. So that is going to be equal to 3 times relative atomic mass of oxygen. Then we divide it by the molar mass of this compound. And what's the molar mass of HNO3? You can do that. Hydrogen is 1, plus nitrogen is 14, and you know it's 1 atom, so 14 times 1. Hydrogen is 1 atom. It's going to be 1 times 1. Then oxygen is 3 atoms. That 3 atoms will give us 3 times 16, or 16 times 3. Then you multiply this by 100. Alright, so let us see what this gives to us. 3 times this will give us 48. Divided by 48 plus 14. If you have 48 plus 14, it's going to give us 62. Then that 62, add 1, you get 63. So the molar mass of trioxonitrate 5 acid is 63. We shall multiply it by 100. So let us find out what this will give to us. Therefore, percentage by mass of oxygen in HNO3 will now be equal to, let me get my calculator. So 48 divided by 63 times 100. I will press that. You can press along with your calculator. 48 divided by 63, then multiply it by 100. So this gave 76.2 approximately. 76.2. 76.2. So you put percent. This simply means that the mass of oxygen in trioxonitrate 5 acid is 76.2 grams by interpretation. Remember I told you it is interpreted as what? Mass. Percentage by mass is interpreted as what? Mass. So we have a 72.2%, simply meaning that there are 76.2 grams of oxygen in this compound. Alright, let's go to question number 2. I'm going to manage this side of the board. So that is percentage by mass of what? Sodium in sodium trioxonitrate 5. Sodium trioxonitrate 5. This is not an acid because there is no hydrogen there. Take note. It's a salt. We call it a salt. But not the salt you eat at home. We'll still treat and learn about acid, base, and salt. Okay? So we'll explain all of those. Percentage by mass of sodium in sodium trioxonitrate 5. So that is going to be equal to sodium. The mass of sodium in this compound is 23. Because you can see the relative atomic mass, 23. And it is only one atom, so it will be 1 times 23. Take a look at this one. That of oxygen in question 1, I did 3 times 16. Because oxygen is 3 atoms in the acid, okay? But in this case, sodium is just 1 atom. So it's going to be 1 atom times 23 divided by, we are now going to add the relative atomic mass of each of the elements in this compound to get the molar mass. Sodium is 23, that is, let me just put 23 there, because it's 1 atom, it will still give us 23. So we would add, nitrogen is 14, then plus oxygen is 16 times 3. Because there are 3 atoms there, is that okay? So we would multiply it by 100. Let me solve everything there, okay? Just work it out once. The denominator here would give us 16 times 3, 48, add 14, and then add 23. So the molar mass of sodium trioxonitrate 5 is 85. So this is equal to 23 over 85. We'll now multiply by 100. 23 in the numerator, 1 times 23 will give us 23. So 23 divided by 85, then we multiply it by 100. This gave 27.1% approximately. 27.1%. So this is the percentage by mass of sodium in sodium trioxonitrate 5. It also means, by interpretation, that in this sodium trioxonitrate 5, the mass of sodium there is 27.1. In our next class, we'll be treating empirical formula and molecular formula. We shall also look at isotopes and isotopy. Until then, do have a wonderful time. Remember to tell your friends, your classmates about the GMAS 41 Support Student Education Initiative Program and encourage them to contact us and join our classes. Remember to do the assignments that will be given to you and submit as at when due. Bye-bye. See you in our next class.